In this section, we're going to study circles and also really study the equations of circles and be able to answer questions about them. So first off, what we're going to do is take a look at the general form of the equation of a circle, which says r squared equals x minus h squared plus y minus k squared. Okay, so what is all this about? Well, the r refers to the radius. Okay, so if I go down in this picture here, the radius is just the distance from the center of the circle out to the edge. All right, so there's my radius. All right, now the h and the k represent the x and y values of the center of the circle. Okay, so what I hope to do is just justify why it is that this equation here makes sense. So what I could say is we know that this point right here is at x is equal to h and at y is equal to k. All right, and let's call this point right out here a point x comma y that's on the circle. So if I look at the triangle that's formed, specifically the right triangle that's formed, using the radius as the hypotenuse, then what we can see is that the distance from the center to the edge of this triangle is the same as x minus h. And the distance from the base of the triangle up to here is y minus k. Now, a fact that we would do well to remember here is that any time you have a right triangle, right, when one of the angles is 90 degrees, if you call the lengths of the sides a and b and the hypotenuse c, we know that from the Pythagorean Theorem that if you square a and you add it to the square of b, that's going to equal the square of c. And so if I apply that to the picture that I have over here, then that produces exactly this formula, right? The r is the c, so c squared or r squared is x minus h squared plus y minus k squared. And so anytime this is our formula, we have a circle. All right, so in example 1, they've given us an equation of a circle, and it wants us to graph it and specifically also label any x and y intercepts that we have. All right, so the first thing we note is that the center is -3, 1. Okay. And going back to the previous page real quick, the form is x minus the x value of the center and y minus the y value of the center. So when I see this minus sign, I see that +1 is the y value. But when there's a +3, I know that that is the same as x minus -3, right? So -3 is the x value of the center. And then I know that 4 is the r squared value, right? So if r squared is 4, then I know that r equals 2 is the radius. So on my graph here, let's go 1, 2, 3, up 1. So I know that my center of my circle is right there. And I know my radius is 2, so I've got to go 2 in every direction from that center. Okay, so I definitely can just go in vertical and horizontal lines to get some of the points that are on the circle. So definitely over 2 from here, up 2 from there, left 2 from there, and down 2 from there. So I definitely got those points. Now the other thing it did want us to do is to find and label any x and y intercepts. So let's remember that x-intercepts are where you set y equal to 0, right, and solve for x. So this is going to be x plus 3 squared plus 0 minus 1 squared is equal to 4, which if I expand this out here, I get x squared plus 6x plus 9 when I FOIL all that out, plus the 1 I get from squaring negative 1 is equal to 4. And so x squared plus 6x plus 10 equals 4, and then of course I can set the left side equal to 0. And then I can find my x-intercepts. You know, I could try to factor, but I can definitely do the quadratic formula. So we'll say x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So negative 6 plus or minus. So inside that square root we have 36 minus 24. So that's the square root of 12 divided by 2. And if I break this up a little bit here, I get negative 6 over 2 plus or minus. And there's a square root of 4 in here, so I can pull out a 2 square roots of 3. To simplify that. And remember, the way that that works is that square root of 12 is equal to square root of 4 times 3, and then the 4 jumps out as a 2. And then finally, to simplify, this is negative 3 plus or minus the square root of 3. Okay, so we have our two x-intercepts, right? So we have negative 3 plus root 3, 0. And we have negative 3 minus square root of 3, 0. But what I really want to be able to do is mark them on this graph somewhere that really helps me graph it accurately. And so what I would want to do here is take what I see right here and approximate it. So negative 3 plus the square root of 3 is about negative 1.3. I put that in the calculator. And negative 3 minus the square root of 3 is about negative 4.7. So when I go over to the chart here, negative 1.3 puts me right about there. And negative 4.7 puts me right about there. And so I can start sketching my circle. And you don't necessarily want to do dashed lines per se. I'm just doing them because it's a little easier for me to keep the shape of my circle if I use dashed lines. All right. So there's a sketch of my circle. I can see that I have x-intercepts here. And notice I didn't bother to look for y-intercepts because I could kind of tell there wouldn't be any. But just so we feel good about the process and how we would know there aren't any, if I set x equal to 0, then we would have 0 plus 3 squared plus y minus 1 squared equals 4. And so you'd have 9 plus y minus 1 squared equals 4. And before I even expand this out, I can see that I'm in trouble because I'm going to have y minus 1 squared is equal to negative 5. And so I know I cannot square a number and make negative 5. So already I can see there's no solution to this. If I was to expand it out, though, of course what would happen is I would end up with a negative inside my square root if I did the quadratic formula. And so that would also alert me to the fact that there are no y-intercepts here. All right, so let's work with equations of circles in a different way. It says, where does the line y equals 2x plus 3 intersect the circle from example 1? So we have this circle from example 1, and we want to know where the line and this circle intersect. So first of all, understand that at the place they intersect, right, both rules, right, the rule that says y must equal 2x plus 3 and the rule that says this equation must be true, have to be true at the same time. So that means if I know y has to equal 2x plus 3, what I can do is just go ahead and put 2x plus 3 in for my y value. So I can say x plus 3 squared plus, instead of y, I say 2x plus 3, but then subtract the 1 that's already there, has to equal 4. And so now I have an equation with just one unknown in it. So this is x plus 3 squared plus, and then I can simplify in there. So instead of 2x plus 3 minus 1, I can just say 2x plus 2. And then we can FOIL things out. So over here, when I FOIL this out, we get x squared plus 6x plus 9. And here we get plus 4x squared plus 8x plus 4. Right? And I'm being a little bit lazy here. Just remember, you know, when I'm doing this, I'm really writing out both of them, right? And so then I can see first times first is 4x squared, right? Outside times outside, 4x. Inside times inside is 4x plus 4. And of course, that's how I get this one, for example. And then I can combine my like terms together and I can solve for x. So I have 5x squared plus 14x plus 13 is equal to 4. And then subtracting 4, we get 5x squared plus 14x plus 9 is equal to 0. And this is one that we can just use the quadratic formula. So I can say x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And this is going to be negative 14 plus or minus, and inside the square root here, let's see, this ends up being 196 minus 180, so this is going to be 16 under the square root divided by 10. So negative 14 plus or minus 4 over 10. And so on the one hand, x could equal negative 14 plus 4 over 10, so that would be negative 1. And on the other hand, x could equal negative 14 minus 4 over 10, so that's going to be negative 9 over 5 when we reduce that. All right, so we have these two different possibilities, but let's understand that based upon these two different possibilities, then there's a y value that has to go with each of them, right? So it's not sufficient for me to just say, well, x could equal negative 1 and x could equal negative 9/5. What we need to do is have the y that goes with them. But at that intersection point, we also know, right, y equals 2x plus 3. So the easy way to do it is just then to plug that x value in to our linear formula. So that's going to give me 1. And then for this one, y equals 2 times negative 9/5 plus 3. So here, we got a little more to do. We have negative 18/5 plus 3, but my 3 could be written as 15 over 5. And so y is equal to -3/5. So these 2 points of intersection should be -1, 1, along with -9/5, -3/5. Now, it would be a good idea here to talk about how we can check this work in our calculator. So it would be nice to plot our circle and plot our line and see if it looks like it's actually intersecting at the 2 points that they're talking about. So plotting the line is really no big deal. So I can just go to my y equals menu and just type in 2x plus 3. No big deal. It's a little more difficult to type this in because we have our y equals menu of the form, well, y equals, right? So the y, in other words, has to be by itself. So what we have to do in order to get in a position where we can even put it in our calculator is we have to take this and solve for y. So I have my x plus 3 squared plus y minus 1 squared equals 4. And if I want to get y by itself, might as well just start by moving some of this stuff over. So this will be minus x plus 3 squared on both sides. All right, and so y minus 1 squared is equal to 4 minus x plus 3 squared. And I'm actually not in too big of a hurry to multiply all this out. I'm just going to leave it this way. And I know that if I have something squared equals something else, I can take the square root of both sides to get rid of this square. However, when I do, we have to remember that on the right side here, it's not just the square root. We have to remember that it's plus or minus the square root. Okay? For the same reason, if I think of the simple problem of x squared equals 4, what number could I square to make 4? Well, yeah, I could square 2, but I could also square -2, and that would also give me 4. So it's the same thing here. And so then lastly, I add 1 to both sides, and so what I get is y equals 1 plus or minus the square root of 4 minus x plus 3 squared. So this is literally 2 different equations that I have to type in. So in my y equals menu, I'm going to type in 1 plus the square root of 4 minus x plus 3 squared. And then in the next line, I'm going to do the same thing, but I'm going to put a minus in there. 1 minus the square root of 4 minus x plus 3 squared. So with all that, I'm going to go ahead and go to my zoom button to make sure I'm in the standard window. So I'll go zoom standard. And then you'll notice I make this graph. Now, I can't see what's going on all that well right here. It looks like I can see 2 intersection points, I guess, but it's kind of hard to see what's happening. So let's get rid of a lot of this unneeded stuff. So really, let's just focus in on this window here. To where maybe we're looking just from -5 to 0 in the, -6 to 0 in the x's, you know, and maybe like -3 to 5 in the y's or something like that. So -6 to 0 in my x's and -3 to 5, I think is what I said. And that should give me a pretty good view of what's going on. All right. Now, if things look funny, they should, because this certainly doesn't look like a circle. But please understand the only reason that's happening is because of the fact that our x scale is different than our y scale at this point. So don't be thrown off by that. But what we want to do is, let's see if I hit trace. I can trace along here. And so if I type in -9/5, let's see where that lands me. Well, it lands me right there where it looks like they're intersecting. -1.8, that is -9/5. And -0.6, that is the decimal equivalent of -3/5. So that's good. And then if I type in -1, that puts me right here at this other intersection of -1, 1. So anytime you want to take a look at your circle, just go ahead and solve for y. But remember the plus or minus in order to get both your upper half and lower half of your circle. The last example we're going to do is one where they tell us the center, but then instead of telling us the radius, they just tell us that the circle also happens to pass through the point -4, -6. So let's understand first that when they tell us the center, what we can do right off the bat is say that we know that the x part is going to look like x plus 1 squared. And for the y, it's going to be y minus 5 squared. But it's equal to an unknown radius squared, right? So I'll just put my r squared right there. But if the circle has to pass through -4, -6, that means that I should be able to plug -4 in for x and -6 in for y, and that should make the equation true. So I can go ahead and do that. -4 plus 1 squared and -6 minus 5 squared is equal to r squared. Right, but of course here I get -3 squared, -11 squared is equal to r squared. And so, of course, you square a negative, you're going to get a positive, right? 9 plus 121 is my r squared. And so I get 130 is equal to r squared. And, we're kind of used to getting r by itself, and that's, we can say that r equals the square root of 130, but at the same time, we know that r squared is the thing that belongs in the formula itself. And so when I write my final answer here, x plus 1 squared plus y minus 5 squared, that's going to equal 130. And that is the equation of my circle.